Welcome again to the next video in the algebra series. So today we're going to be looking at this idea called expanding brackets. Okay, it's another one of the tools that you can use to manipulate expressions and equations later on in different ways to make them easier, or if there's a particular thing that you want to do. Probably one of the things that in this start section, especially of your algebra, is you're learning a lot of techniques but not really doing a lot with it yet, maybe. It's kind of like once you think about it like a tradesman, you are currently filling up your toolbox with a whole bunch of different things, because when you go to attack a problem using algebra later on, and because you're not necessarily always told, here, do this thing, you just want to sit down and you'll look at it and you think, right, for example, if you're going to, if you say to yourself, right, I want to build a house, okay, and you're saying, and so the first thing you're going to do is go, right, well, I think I'm probably going to need to put the frame up first. Okay, so then you get out the tools that you'll need to put the frame up, your hammer, your nails, your saw, that kind of stuff, and you go about it. Okay, rather than just sort of like grabbing these detailed instructions from start to finish of how to build this house. Okay, it's kind of what's happening at the moment with the algebra. You're getting a whole bunch of different tools sort of brought together for you. Okay, right, but this first one, expanding brackets, you're going to need to be, we're still connecting the laws and properties for numbers to algebra, okay? And at the end of this one, you want to be able to expand a set of brackets inside some expression. Okay, so what we're going to be doing today is thinking about this idea of algebraic areas. Now, I know you may not have done area yet for, as a normal unit, but sort of just flow with me. You've probably seen this kind of thing before in primary school, but here we've got a rectangle, okay, and we'll just write up here for the sake of our sanity, the area of a rectangle is equal to the length times the width of it, okay? All right, so the length, width, doesn't matter which one you go with, it's just one of the lengths times the other length, okay? Now, if we have a look at this rectangle here, there's a couple of ways we can go about talking about its area, okay? So the first one is saying that let's call this part area 1 and call this part area 2, okay? So we can work out each single piece of those. So let's look at area 1 first, okay? So if area 1 is equal to its length times its width, that means it's going to be this one times this one up here, so 4 times 3, which is 12, okay? And if we've got area 2 is also a length times a width, okay, this length here is also 4, okay, because it's the same as this side over here, and this length here is now y. It's an unknown amount that we don't know about yet, okay, so we're going to have it is equal to 4 times y, which is 4y, okay. Now, therefore, give myself a bit of space here, therefore, the total area is area 1 plus area 2, right? Which is 4y plus 12. Okay, you're okay with that. That's just that area. But we could also look at it as the whole, okay? So let's also look at another way to work out the area. So the area would be in length times a width. So let's go this length here of 4 times the width will then be the entire length of this section here, okay? And that's going to be 3 plus y, okay? But that's the whole width. It's not 4 times 3 plus this extra bit of y. It's 4 times 3 plus y. And you've seen that before, that we could rewrite that as 4, then 3 plus y inside the brackets, okay? So, what does that mean? Well, it means that, therefore, these two expressions here, this one here and this one here, must be equivalent because they're both correct representations of what that area of that large rectangle here is, okay? So that means it must be true that 4y plus 12 is equivalent to 4 times 3 plus y. All right, so there must be some kind of mathematical way that we can get this to become this, and vice versa. Okay, so today we're going to be looking at how to go from brackets to something without brackets. Okay, so let's scroll down, have a look at some key ideas. Right, so we expand a set of brackets using the distributive law. Okay, so the same kind of thing that you could use for any kind of brackets to be able to expand things out. We're going to be doing it now with algebra. All right, so here's the important thing here. The factor outside the brackets is distributed to every term inside the brackets, okay? Now, the way I'm going to show you how to set this out is a perfect way to avoid making any errors with this expansion stuff, okay? So, I'm just going to rewrite it for ourselves. Oh, we don't really need to. So, right, so we've got 2x plus 3. So what it means by distributed is that this 2, and I want you to draw these arrows, it's really important. So this 2 gets multiplied onto the x and multiplied onto the 3, okay? So these are multiplications, all right? So when we expand this, my next line is going to look like this. 2 times x, making that a bit too big. All right, so our next line is going to be 2 times x plus, okay, this is what's important to move down the page, because this plus just gets moved straight down, plus 2 times 3, okay, 2x, 2 times x is 2x, plus 2 times 3 is 6. Okay, now here's the other thing for you to notice, that the number of terms that were in this brackets, there's 2 terms, there are 2 terms left when you expand it. Super important. If there were 3, you would be left with 3. Okay, so that's an important one to remember. The number of terms inside the brackets is the number you're left with when you finish expanding. Okay, a couple of worked examples for us to look at. All right, expand the following expressions. Can I move this out a little bit? There we go. It's a lot easier to work with now. Okay, so we have 5x plus 2. So let's put our numbers. 5 is multiplied by the x and by the 2. So we have 5 times x plus 5 times 2, which is 5x plus 10. Okay? Probably really starting to get the hang of this even now watching this video. Okay, it's not necessarily one of the more difficult things to do. The hardest thing to remember is to distribute onto the extra terms in there. Okay, it will be very tempting to just get rid of the bracket and just have the first one term. Okay, so here we have 8 times b minus 3. So the 8 gets put onto the b and gets put onto the 3. So we have 8 times b is 8b. Well, let's write it 8 times b. The subtraction just comes straight down. 8 times 3. And we've got 8b minus 8 times 3 is 24. Okay, there's our distributive law at work. That's what's called the distributive law, because it gets distributed across all the factors, over all the terms. Okay, last, this one's a little bit trickier, but you'll be able to deal with it, promise. Okay, so again, what you need to realize in here is that this whole thing out the front is a term, this is a term, and this is a term, okay? Right, so that means that this gets distributed onto that, and this whole thing gets distributed onto that, all right? So we're going to have 3a times 4m minus 3a times 2n. Okay, so 3a times 4m, 3 times 4 is 12, am minus 3 times 2 is 6, a times n is a, n, done. Okay, so that's probably one of the newer, more interesting tools that you've seen, and hopefully at the start where I showed you how it relates in with areas and things, that kind of helped you sort of gel together with what's going on here. But again, practice, practice, practice is going to be the best way just sort of hammering through this stuff. Okay, thanks so much for watching, and I'll see you at school.